Hi guys! In the previous video, we have learned how to make a graph of transformed sine and cosine function. In today's video, we will be learning how to turn a graph into an equation. So we have already done how to turn an equation into a graph. Today, we'll be doing an opposite thing, that is turning a graph into an equation. Let's say we are given these two different types of graphs. Let's call this question number 1. Let's call this question number 2. As we saw in the previous videos that there are steps to turn equations into graph, similarly there are steps to turn graph into equation. Let's go over the steps first. So step 1 is read your max and min. In this particular example number 1, I have my max at, we try to see this is at 3, and I have my min at 1. Step number 2 is to find A and C. We can find out A and C using max and min points. As we know, C is max plus min divided by 2. Max is 3, min is 1 divided by 2. Gives us a 2 because 3 plus 1 is 4 divided by 2 is 2. A is equal to max minus min divided by 2, which is 3 minus 1 divided by 2, and this is 2 by 2 is. Next we have is step number 3. Step number 3 wants us to find k value, and as we know, time period is 360 divided by k. If we isolate it, from there we get to know that k is equal to 360 divided by time period. Time period is something that we can get from our graph. Let's look at the graph. As we know, time period is time taken to complete one full cycle. And now we will observe something, that one full cycle is completed when we go from max to max. This gives us a one cycle. Or when we go from min to min. This gives us one full cycle. When we look at this problem, we see a min point which is at, we can say 4 and 1. And we see a max point which we can see is at approximately 10 and 3. Now we do not see where is the next min or where is the next max, because the distance between a min to min or a max to a max would give us the time period. Since we're just given one min and one max point, so from here we would conclude that min to max is a half cycle. Similarly, max to min is also half cycle. Now we'll check what is the amount of our half cycle. Our half cycle goes from 4 to 10, which is, if this is in time period seconds, then we can say our half cycle is 6 seconds. If we do not have any units, we would just say 6 units is the half cycle. Half cycle means half time period is 6. But do we need half time period? No, we need full time period. So full time period will be 6 multiplied by 2, which is 12. Going back to the step, we got our time period to be 12. So we'll find out the k value is 360 divided by 12. That is going to give us a 30. Now the next step is step number 4. Determine your parent function. We'll go back to the graph and we'll understand how to determine our parent function. As we know, our parent sine function graph looks like this. When a is positive, we have the first point at 0, which is the midpoint, then max, then mid, then min, then 0. If a was a negative number, then the same graph will just reflect over x-axis and will look like this. We would have mid, min, 0, max, and mid. Now we would compare this and see, do we see anything matching like this on the question that we are trying to find out the equation for? In this, we can't even find our midpoint. Let's consider that the midpoint is 2 because your min is 1, your max is 3. So if my midpoint is 2, this would be my midpoint, or this would be my equation of axes. If I take my start point here, then my graph would look something like a sine graph. Mid, max, and then when it will continue, it will go to mid, min, mid, and then max, and so on. But if I consider this as my start point of the graph, I am unable to locate my central value. I don't know, it could be any decimal number. I don't want any approximations. So I would instead start my graph at this point, because this point I know both the x and the y values. If I start my graph at this point, so this is my min point, I'm gonna go back and check my parent function graph and which one starts at the min. This is my parent cosine function, which starts at a max point, then goes to mid, min, mid, max. If I make my parent cosine function where a is negative, so this is where a is positive, then my start point will be min, 0, max, 0, min. This is how my graph is going to look like. So when a is negative and my parent function is cosine, my start point is a min. Then it goes up to a mid. I'm gonna see that this is something that represents the question that I'm writing the equation for. And I notice I have a min point, I have a midpoint, I have a max point. So this looks like a cosine function. So the function that I would select for my equation is going to be a cosine function. In this particular example, I have a cosine function. Then step number 5 is I have to determine phase shift. That is the d value. D value is very easy to determine. Let's see. As we took this as the start point, everything from the y-axis to the start point is going to be your d value. And you see the d value is 4. So the d value that we have obtained in this particular example is 4. We'll put all these steps together and we'll write down the parent transformed function equation. A, because we selected our function to be cosine, k, x minus t plus c. Now all we have to do is just sub in a, k, d and c that we have obtained in the previous steps. The a value that we have obtained is 1. K that we have obtained is 30. So we would sub in A as 1, K as 30, D we got as 4, and the C value, let's go back again, is 2. And with this we have completed our transformed equation for the given graph. Let's take up the second example. So our first step is to write down the max and the min value. Our max is at 6. Min is at -4. Use these max and min values to find out A and C. C is max plus min divided by 2, which is 6 plus minus 4 divided by 2. That is equal to 2 over 2, which is equal to 1. Similarly, we find out our A value is max minus min divided by 2. That is 6 minus -4 over 2, and this gives us 6 plus 4, 10 divided by 2, which is 5. Our third step is to find the k value, and we know k is 360 divided by time period. Time period, we'll go back to the graph to read. As we know, time period is the time taken to go from max to max or min to min. We would see, do we have a max? Do we have another max to check? No. Let's check min to min. Do we have a min? Yes. Do we have another min? Yes. So we have 2 mins to check what is the 1 cycle time. And we'll just see that this is at 1 and this is at 9. So time period from 1 to 9 is 8. All we have to do is just sub in t as 8 and put it on the calculator. This gives us a k value of 45. Next step is to find what function are we going to use for this particular graph. Now deciding what function you want to use is completely personal choice. And the choice depends upon where you want to start your graph from. Now let's say I want to start my graph from this highest point, and then I see my highest point is the start point in which parent function graph. And I notice that the highest point is the start point is a parent function graph where function is cosine and a is positive. So if my start point is a max point, then my parent function will be a cos, and my phase shift will be everything from y-axis to this max point, and I always have to read it on the x-axis, and that is 4. So my phase shift is 4. I'll put this all together and write on the equation. So my equation is going to be y is equal to a cosine k x minus d plus c. The a value that I have obtained is 5, cos k value that I've got is 45, d is 4, going back to check the c value, and we see the c value was 1. So this is our equation for this graph. Now let's say if I want to select a different start point for the same example too, then first step, second step and third step would stay the same. Fourth and fifth steps would alter. And step number 4 is determine parent function. We'll go back to the graph and see some other point as the start point. As now I know that my c value is 1. So my axis of symmetry is going to be at 1. I'm going to make my axis of symmetry and I choose this to be my start point. If this is my start point, from here my graph is going up this way. So it's a mid, max, mid, min, max. And where do I see my start point to be a midpoint going towards upward direction? I'll compare it to my parent function. And I notice here is that when I am on my parent sine function graph with a positive, my graph starts at the midpoint going upward. So this start point represents my sine function with a positive. So in this case, I have my start point as mid going up, means my function is going to be a sine function. If my function is a sine function, my step number 5, that is my phase shift, would be everything from the y-axis to the start point, and that is 3. So my phase shift is 3. That means now my equation is going to be y equal to a sine k x minus d plus c, where my a value is equal to 5, parent function is now sine, k was 45, phase shift is now 3, and the c value was 1. So you will notice that your a value, k value, and c value, that is step 1, 2, and 3, will not change. The only thing that will change if you change the start point is your parent function and your phase shift. And this does not change your answer. It's just that you have multiple answers for a given graph. So you can represent this graph equation as this with sine as a parent function, or this with cos as a parent function. Both equations for this graph is correct. Similarly, for every graph you can have multiple equations.